So what is a radian? Well, a radian is another way of measuring an angle. So we have many different ways to measure the same thing. If I ask someone, how tall are you? Brody, how tall are you? Just under 6 feet. Okay. Emily, how tall are you? Whoa! You're just under 6 and she's 169? How is she so much taller than you? Different measurements, right? She's using centimeters and you are using feet. You have to know those different measurements. Otherwise, we would think that Emily is a giant or Brody was a midget, right? And those things, it's important to know those different measurements. I mean, we have other things that are different measurements. Someone owes me $5, so they could give me 5 Canadian dollars, 5 American dollars. What other countries use a dollar? Australian. So some of those would be better than others. And if you just say, I owe you $5, quickly go get my Australian money and go, ha. I don't know, is Australian money worth less? I just pretended it was. Because they're, oh, I thought because it used to be thieves that went to Australia, their money was worth less, but I'm not. Anyways, so we have different measurements of the same thing. A radian is another way of measuring an angle. So if we make a circle, I'm going to make a pretty circle here. I'm going to make my circle about this big. There we go. Yeah, here's a triangle. This is a special triangle for helping you learn about radians. It's also a special triangle when talking about triangles. Does anybody know the name of this triangle that I'm holding? It's an equilateral triangle. An equilateral triangle has all the same sides. So what I've done here is if my center looks like, if I line things up here, my center is right about there. If I draw an equilateral triangle in there, it would look like that. What are the angles of an equilateral triangle? 60 degrees. So all of these would be 60 degrees. Okay? Now, the reason that radians are used a little bit more, one of the reasons that radians are used a little bit more in higher mathematics is the definition of a radian is related to a circle. It's actually related to the measurements of that circle, whereas a degree is an arbitrary measurement. Someone decided we'll put 360 degrees in a circle. Okay? And that was a nice way to separate things, right? If someone decided there was 1,000,000 degrees in a circle, your protractor would have way too many lines. Okay? Some calculators have gradients instead of radians or degrees. And sometimes they've decided, well, 90, why 90? Why do we use a 90-degree angle? Right? One of the reasons we changed from feet and inches to meters was so everything would be in hundreds. So someone has done math where instead of 90 degrees, it's 100 degrees. And there's 400 degrees in the circle. Would that make math easier or harder? Well, since you've used degrees, you'd probably say harder. Just like everybody who used feet and inches when they decided in Canada to switch to meters and centimeters, they're like, that's harder. It's just because of what you're used to. But a radian measure is actually connected to a circle. And the definition of 1 radian is the angle when the arc length equals the radius. So if on my circle, and this is where this triangle comes in handy, 2 of those sides of that triangle are the length of the radius, right? I need to take this length, and if I had a piece of string, I could measure it out perfectly and then bend it and put it along the edge of the circle. Would it get all the way to that other point, or would it be a little bit short? A little bit shorter. So maybe about there. And you can imagine if I take out my special triangle here, if I actually take this and bend it, eventually I will get that curve on the edge of that circle. But when I push that down to bend it, what happens to this angle a little bit? It gets a little bit smaller. So right now we could estimate. If you looked at this and you estimated what you thought 1 radian would be, what would you estimate? What? 58.2. Oh, I like. Okay, that's not the actual number, but that's a nice, makes you sound confident, right? Whenever you go into, if you ever make a mistake, like you go into a building you're not supposed to go in, you just pretend you're confident, right? And just keep walking like, I know where I'm going. And then you walk right out. There's some places that can be useful. Some places where it doesn't help to look confident, right? You go into the wrong washroom. Even if you look confident, everybody knows, yeah, that was a mistake. And okay. Yeah, I paused the recording, but now we'll be laughing for the next little bit, so they'll just wonder what happened. So now, if we take a circle, again, make a new circle, and now we try to figure out exactly how many radians are there in, like, what is 1 radian exactly in degrees? So if we start with our center of our circle, and, ooh, that's pretty. And there is our radius. Yes?
If 1 radian is the angle when the arc length equals the radius, wouldn't a radian be different for every circle?
No. That's a good question, though.
No, because
No matter how big or how small you make a circle, so I will demonstrate it here. If I make a small circle, the radius is smaller. And when I draw that arc along the edge, it's still just a little bit less than 60. Because I would have a littler triangle that I would squish. Okay? Would there be 2 pi radians in a circle? Well, if we started by doing our first one to here, right? And our next one would be a little bit less than 60 again. And a little bit less than 60 again, we would have 3 of them wouldn't be quite at 180. And then another, we would get 6 of them and a bit. And you're saying, is that 6? So here what we're trying to figure out is radians in a circle, 6 and a bit. And someone is saying, is it 6.28 ... or 2 pi? If we're going to say something very exact, like 2 pi, we're going to need a better explanation than just 6 and a bit. Well, 2 pi is 6 and a bit. Our diagram is 6 and a bit, so therefore it's 2 pi. That doesn't seem like a very strong logical argument. But it works. Why?
The diameter, sorry, the radius is half of the diameter.
Okay.
The radius times 2 pi is equivalent to the circumference.
Okay, that's important. That's important to say that we know that our circumference is 2 pi r, or 2 pi times the radius. And a radian is the same as a radius on the edge. A radian as an angle, 1 radian here, is always equal by definition to the 1 radius on its arc, no matter how big or how small. But just like the circumference formula is the same formula no matter how big or how small the circle is, because there are always 2 pi radiuses that would go around a circle. And so the number of radians in a circle is 2 pi. So now we have that information. That's important. Okay? Because when we talk about things being the same, 10 inches is the same as 25.4 centimeters. Those are the same. And we can take that and figure out that 1 inch is 2.54 centimeters. We have information here to compare degrees and radians. What do we know now? How can we say something in radians is equal to something in degrees? What numbers would we use? We want something in radians to equal something in degrees. What numbers would you like to use? So 2 pi radians is how many degrees? 360 degrees. Okay? Can you tell me how much pi radians is then? 180 degrees. Excellent. Can you tell me how much 1 radian is? Well, it's a little bit less than 60. We estimated 58.2 already because we squished that triangle just a bit. How would you do that? We know that 2 pi is 360. You were able to find pi was 180. How do I find 1? Take 180 and divide it by pi. What is that? How close were you at 58.2? Sorry? 57.3. Oh, if you would have taken 1 from the 8 and added it to the 2, you would have been perfect. So close. So 1 radian is about 57.3 degrees. Pi radians is 180 degrees, and 2 pi radians is 360. How many degrees, how many radians is 1 degree?
For degrees, you have to write like little degrees of
Yes.
radians in it.
No, there isn't a unit. So when you talk about an angle and you say the angle is 2, you are assuming radians. There's a symbol. When you forget the symbol of degrees, did you lose a half mark in grade 11 once because you forgot the degree symbol? Yeah, probably. That's because technically, without knowing it, you were writing radians. So if you wrote 180 and forgot the degree sign, you wrote 180 radians, which is a very, very big angle. Because all the way around one circle is 2 pi, or 6.28. So 180 would be like just a little bit less than 30 times around a circle. That's a lot of spinning. Okay? Now, they haven't changed that for, language. If you do a 180 and you didn't say degree sign, it's not like you spun 180 radians in the air, which would be crazy. It'd be really impressive. Okay, but 1 degree. So how would you figure out what 1 degree is in radians? Sorry? Divided by pi? Not quite. So one of the things that we notice with a chart like this, okay, when we're comparing things, we can go from one thing to another by, like if I divided by 2 on this side, I can go from 2 pi to pi, but then I also have to divide by 2 on this side. And so we got the 180 over pi because we took pi, and how would I get 1? I would divide by pi. So how would I get from here to here? I'd divide by pi. So if I wanted to get from 1 from something I already knew, which number would you like to use? Want to use the 180? How would you get from 180 to 1? Divide by 180. So then 1 degree is going to equal pi divided by 180 radians. Now these last two, some people really like these last two and like to memorize them and use them, okay? Because if you want to find out, because one of the things you're asked often in this course as a straightforward question is to change 20 degrees to radians, or change 3 radians to degrees. And if you have those two values, it's quite easy to do that. If I want to change 3 radians to degrees, I could use this one, right? Because to get a 3 on this side, I'd have to multiply by 3. So then 3 radians would equal 3 times 180 over pi degrees. If I wanted to change 20 degrees to radians, well, I'd use the second formula here. What would I have to multiply the second formula by? 20. So it'd be 20 times pi over 180. Of course, think of that as 20 over 1 when you're multiplying fractions. And so the answer would be 20 pi over 180. And you could reduce that fraction if you wanted. Or just leave it as 20 pi over 180, or could reduce it to pi over 9. Could also write it as a decimal, but most of the time we'll leave things as exact answers. So these are radians. Did I have anything at the top of this page? No, this was a new page. On the top of page 489, see if this is where, yeah, there it is. This is what you have at the top of page 489. They have that same idea of 2 pi equaling 360. That comes from the circumference, which we looked at. The other thing that we're going to want to add off to the side here is something about arc length. The formula that we discovered this morning was that our arc length was equal to, and I don't know why, but the symbol for arc length on your formula sheet is an S, because obviously the word arc starts with S. Okay. Probably because too many things, area, all your area formulas start with A, so they can't use A again. So they went with S. So if someone can think of a creative reason why it's S, that'd be great. Anyways, what we discovered this morning is that our arc length was whatever proportion of 360 degrees times by our circumference, 2 pi r. That was our formula that we developed this morning in our math lab, right? Now we're going to change this formula to radians. So this is our formula in degrees. In radians, the formula would be identical. But now instead of theta over 360 degrees, we would have theta over 2 pi, because 2 pi radians is the same as 360 degrees. And you would still multiply that by your circumference. Now, this formula is just too tempting not to simplify. Can you see something that's going to simplify really nice? The 2 pi's are going to cancel right out. And the arc length formula in radians is just whatever your angle is times by your radius. Which makes sense, because if I do a simple example here and I tell you that this angle is 2 radians and my radius is 8, well, every radian is 1 radius on the edge. So if I have 2 radiuses on 2 radians, my edges are just going to be 16. And so my formula for arc length in radians is really simple and really nice. And that formula is the first formula on your formula sheet.